In this video, we'll be going over factorial trailing zero. So given an integer n, return the number of trailing zeros in n factorial. In the follow-up, could you write a solution that works in logarithmic time complexity? So for example, we're giving n is equal to 3 and 3 factorial goes to 6, so there's no trailing zero, so return 0. Our second example, we're given 5 and 5 factorial is 120, which contains 1 trailing zero, so we return 1. Let's go over the thought process. So let's first find out what contributes to the trailing zeros. If we multiply a number by 10, we will get a trailing zero. Now 10 is a multiple of 5 and 2. This means anytime we see a 5 and 2, or this pair, we will get a trailing zero. Now, since the occurrences or the frequency of 5 is always lower than the frequency of 2, all we need to keep track of is the frequency of 5s. Now, how can we find the number of 5s inside n factorial? We can use division. So for example, if our number is 10, if our current number is 10, if we do 10 divided by 5, we get 2. And this means 10 factorial, we will get 2 trailing zeros. Now, a side case we have to handle is multiples of 5. So for example, the number 25 contributes to 2 5s because of 5 times 5 is equal to 25. Or it's not only 25, it's 25, 125, and also all of the other multiples. This means we will need to account for multiples of 5s. So let's go over the pseudocode. So we're going to create the following variables. The first one is zeros, is the number of trailing zeros. And then we have multiple, our current multiple of 5. So initially going to be 5. So while multiple is less than or equal to n, this means we still have multiples of 5s to account for. We're going to increment zeros by n divided by the current multiple. Then we're going to multiply the multiple by 5. Then we can return zeros. Now let's go over the time and space complexity. For the time complexity is of log n, where n is the input value. This is because we divide by multiples of 5 each time. Then our space complexity is of 1. Now let's go over the code. So we're going to create the variables to keep track of the number of zeros and also the number of 5s, or the current multiple of 5. And then while the multiple is less than or equal to n, we're going to increment zeros by n divided by multiple. Then we're going to multiply multiple by 5. Then we can return the number of zeros, the number of trailing zeros. Let me know if any questions in the comment section below.